Okay, good. Now we can also multiply and divide. And it's really just the same exact rules as with fractions of integers. It's the same exact rules. In other words, to multiply and divide rational expressions, two of them, to multiply them, as you can see, you multiply the numerators and multiply the denominators. To divide, right, which is the same notationally as this, you're dividing a fraction by another one. Remember, what you do is you flip the second fraction. You flip the second one, right? You invert it as over here. You take its inverse. Excuse me, you take its reciprocal, that's better. And then you multiply. That's what we do. So then you multiply. Okay? So again, it's just like with integers. All right. Here's an example. Let's multiply these two and we'll simplify as well. And what I wrote here about leaving the denominator in factored form, you can do that with me. Okay, you can always leave it in factored form. So nothing wrong with that. So to multiply, what do we do, right? Well, again, you want to just multiply them together, right? So we end up with this. So there's not much to it. But to simplify, notice that we have a common factor of x plus 1, so we can cancel it. And from here, we get x squared plus 1 over x minus 3. That's what we get. All right, so that's what we get here. Okay, for the second one, it's similar, right? You know, all you do is you just multiply the numerators and denominators together. Now, I would not actually FOIL, just like we did not FOIL here. Don't FOIL the top and bottom because we're simplifying as well. Even if we weren't simplifying, you don't have to do that. With me, at least. Right away, you can see we can cancel something, although that'll come shortly. I mean, we can cancel x plus 2 from top and bottom, right? Notice also that x squared minus 1 we can factor. We couldn't factor x squared plus 1 because a sum of squares you cannot factor. A difference you can. Yes, this is a difference of two squares, right? We had x squared minus b squared, where b is a number, a positive integer. We get x minus b times x plus b. Okay, so in this case, we have b equal to 1, and we have this, factored it. From here, we can now do a bunch of canceling, right? You can see the x plus 1s are gone. The x plus 2s are also gone. They cancel. All we're left with is x minus 1. All we're left with is x minus 1. Okay? Any questions on that? All right, for division, it's similar, except there's an extra step you have to take. You have to take the reciprocal of the second fraction. So in other words, for this here, right? Okay, what we do is we actually have to flip the second fraction here, right? That's what I did. See? From here to here, we flip it. And then we want to multiply, like so. And again, we're going to simplify as well. You only have to simplify if I ask you to, okay? You only have to simplify if I ask you to. Now, right away, you could simplify a bit, namely the x minus ones you can cancel, like so. So those are gone, and we're left with this. Now, the numerator is pretty easy to factor. I mean, I know we could have used the factor theorem, but let's just factor right away because the top is easy to factor, right? Namely, for the top, right, you wanted two numbers whose product is 2 and whose sum is 3, right? Because this is a trinomial, leading coefficients 1. Well, the two numbers are 2 and 1. So we get the top over here is x plus 2 times x plus 1. Okay, so we put it in for the top. And again, we can actually simplify, right? You could see that the x plus 2's cancel, and we get this. So all together, what we get then is this. From here, we get all the way down here. Are there any questions on that? All right, cool. So this one I want everyone to try. Let me just stop the recording. Then we'll go through it together. So I'm going to pause the recording.